Okay. Just started recording. Sorry, guys, we did a little bit in advance. We came up with 2 points. We circled them. We jotted them down, and now we're finding the slope. So it's 125 minus 2 over 2 minus 8. Did everybody get negative 125 over negative 6?
Yeah.
About? Where, Harrison, what'd you get?
I got 150 over 7.
Okay. Everybody grab your calculators now. Question.
Oh, you get 250 minus 125.
Yes, you get the same answer. My numbers are both negative. When you divide 2 negatives, what do you get? You're going to get 2 positives when you divide them. So it's going to be the same thing. So everybody divide that out, because on these, when you write your equations, okay, you're going to see, we're going to just, what'd you get, Ange, when you divide them out?
20.8
With a 3 repeating. Okay. Do you agree it's real close to 21? I'm going to use 21. Some people last period used 20.8. Either one is fine. Look how close they are to each other. So I don't care which. You want to use 21, that's fine. You want to use 20.8, that's fine. It's close to each other. So now, we know M. Remember, we're talking about slope-intercept form. Y equals mx plus b. B, the y-intercept, is staring at you in the face. Raise your hand when you got it. Blurt it out. Who thinks they know what B is? So easy. Oh, stop.
125.
It is not 125. That's what they said last period. It is not 125.
Is it in between 75 and 85?
That was just it.
Or 75?
80.
But you're on the right track. Shushko,
90?
I got between 90 and 80. Okay? How are you getting that? How is she getting that? What is B? Where does that line cross the y-axis? Look. What do you guys think? Okay? Again, 75 and 100. I think, what would it be? 87.5. So, I think it's 90. I got 90 actually when I did this problem. If you did 85, you would get it right. Okay? What if you did a y? Is that 50? No. Is that 100 even? No, too big. It's somewhere in between. So I'm going to use 90.
So that's why we have to continue.
Yeah, making connections. Very good. When you make your lines, guys, make sure they hit the y-axis, because that's your B. All right, everybody, write their equation. You're done. It's easy.
Wait, how'd you get 90?
Okay, where does the line, look carefully, cross the y-axis?
Cool, I got the
So
same.
you-
Where is the y-axis? Right, where does that line cross the y-axis? There's always a dozen. Because that's what B represents with y-intercept. So, who's got the equation written? The easy part. Pabone. Thanks. Harrison, what was your equation? Because you used different.
Y equals 21x plus 90.
Oh, you got your slope was 21.
It was 21.4 to 8.
21.4. Guys, if Harrison uses 21.4 instead of 20.8 or 21, is that close enough? Yes. You know why? He's showing work. He's showing his points and circling things. He's doing all the right things. Okay. Now,
Thank you.
this is the hard part. You have to interpret the slope in the y-intercept. That means you have to say something intelligent about the slope. And then, so here's my question. What does 21 represent in this problem?
The years.
The slope. No. That doesn't cut it.
Except
For this problem, what does 21 represent? Some of you are going to get it.
The positive association.
Subscribers per year. Years per subscriber. Represents the slope.
Okay. But I want words. What does 21 represent?
21 million subscribers.
How many
Every
year.
Tracy's got it.
Yeah.
Listen, because the slope is 21, every year, 21 million subscribers subscribe. Gain. Again. So,
21 million.
21 million per year. Okay? That's what the slope means. Now, here's the tough question. Don't blurt it out. Think and raise your hand. What does 90 represent?
How much years since 90?
What does 90 represent?
Subscribers that were already subscribed.
Try to verbalize it. Choose go. What is 90?
Subscribers that were already there.
When?
When they started.
No, in 1999. Guys, in 1999, there were 90 million subscribers. And every year, we're getting about 21 million more. Okay? Subscribers to cell phones, I think. Subscribers to cell phone service. All right, now, you're going to make a conjecture. Okay? We said a conjecture is like a hypothesis, an educated guess. Okay? A prediction. In the year 2015, how many subscribers are we going to have? Okay? There's always one kid that starts at 1999 and just keeps adding 21 until they get to the year. Bad way to do it. Takes too long. Here's my question. 2015, is anybody smart enough to, don't blurt it out, what is X in the year 2015? Because remember, at the beginning we said, this is 1999, and each of these numbers are 1 year since then. So that's like year 2000, 2 is 2001, 3 is 2002. So what's X in the year 2015?
16.
Angie? 16. Does everybody agree with that? X is 16 in the year 2015 because X represents the year since 1999. So here's what we're going to do. We're going to take our equation and put 16 in for X. 21 times 16 plus 90. Grab your calculators and figure it out. Let's see. 21 times 16, I wrote that down somewhere. 336 plus 90?
426.
Y equals about 426 million subscribers in the year 2015. Okay? That's one problem.
What?
You only have like a couple of these to do. Okay? All right, let's try another one. You'll be amazed at how fast and good you guys get at this.
Thanks.
All right, the scatter plot shows the graduation rate of high school students.
Yikes.
All right, graduation rate of high school students. Looks good to me as far as more kids are graduating from high school every year because there's a positive relationship there. It's going up. So let's write the equation in slope-intercept form. Okay, jot this down, guys. Y equals mx plus b. The more you write it down, the more you're going to remember it.
I already
Okay, what I want everybody to do is to circle 2 points that are far away from each other on the line. Don't worry about the points. The line is already drawn for you.
Ooh, that's a good one.
Carmen's give me 1 point that you would use.
160.
Yeah, guys, right here. 160. Always start. So 160, and then kind of go far away from that point. Who can give me another point that's clearly on that line? Teddy, what do you want to use?
7, 7.
Yeah, those are the 2 ones that I use. 7, 7. Even though that's a little bit below it, totally fine.
I would choose 8. Yeah, you would choose 8.
Right, because now you guys are looking at the points instead of the line. Because that's what they said last period. They're like 870. The point is closer than this point. I'm not even looking at these points, people. I'm looking at the line only.
You could use 4,65.
Wait, who said what?
You could use 4,65.
Oh, yeah, 465 would be fine as well. But like I said, I really try to encourage you guys to use points that are as far apart away from each other as you can. Not that it matters. Okay? It's just a good habit. What's your...
It's just a line.
Yeah, so look at where the line crosses a perfect the X and the Y lines when they meet.
I thought we were looking at dots on the
No. Well, those dots are not on the line anymore because we drew our line of best fit. Okay, so let's use 160, 770, or if you want to use 465, that would work too.
Bless you.
Excuse me. Make sure everybody's awake. All right, go. Find the slope. To what? Oh, that's a good question. 60 minus 70 over 1 minus 7. Negative 10 over negative 6. Oh, what's negative 10 divided by negative 6, guys? 1.6 repeating. I'm going to use 1.6, or you could use 1.7. You rounded it to the nearest 10.
What happened if you use 2? I can't use 2.
2. That's kind of a big change. That's like, think about it. Changing to 2 from 1.6 is kind of like changing 16 to a 20. With the decimals over once, same thing. So, I think you're going to be okay if you round it to 1 decimal spot. You can use 1. Actually, smart thing to do would probably be use 5/3 as our slope, because we talk about slope in rise over run, and there's the numbers right there. Negative 10 over negative 6 is really 5/3, but I'm going to use 1.6. Okay, I think changing it to the nearest whole number when it's so small.
Bless you.
Angie's going to clear it up. Bless you, bless you.
Thank you.
Round it to the nearest whole number if the number's big, Angie. 1.6 is so small, when you round it to the nearest whole number, you're changing it a lot.
Okay.
If it says 90.6, I would change that to 90. But 1.90, whatever. All right, everybody guess where the line crosses the y-axis. Find your B right now.
59.
59.
Booyah.
Guys, that line clearly crosses the y-axis at 59-ish.
Don't be so mean.
Harrison, do not blurt out. You're blurting out too much. All right, who's got the equation written? That should be done by now. Henley, what is it?
Y equals 1.6 x plus 51.
Plus 51.
59.
59. There we go.
I did 0.
59. All right. All right. Do not blurt this out. What does 1.6 represent here? Too slow. No. More specifically, what does 1.6 mean in this problem? Say something intelligent. Gracie.
The graduation rate goes up by 1.6%.
1.6% every year, the graduation rate goes up. Very good. 1.6% increase every year. That's a good thing, people. More kids are graduating. That's a good thing. Okay? What's the 59 represent? See if you can figure that out.
59% already.
Go ahead, Catherine.
The rate of graduation
Was what? Guys, in 1998, only 59% of the kids graduated. That's bad.
Yikes.
Okay? It's not good.
Is this at one school or is
I don't know where they got that. Hopefully that was not the.
America.
Hopefully that wasn't America, or I don't know where it was from.
Maybe it's just a state or like a county.
All right, here we go. Use that equation, guys, to figure out the graduation rate in the year 2020. 5 years from now. Okay? Everybody try to figure out what X is first. That takes a little bit of time. In 2020, what will X be?
22.
Good, Ange.
22.
22. And some people you subtract them, guys, to get that.
That's what I think.
If 0 is 1998, 2020 would be 2020 minus 1998. So take X, or excuse me, take 22, plug it in for X. Use your calculator. Let's figure this out. Y equals 1.6 times 22 plus 59. Angie, what's the graduation rate in 2020? Or
It is
2020?
96.4%.
Somebody verify that.
Verified.
96. You got 0.4?
Yeah.
I'll buy that.
Because I did 27.
Okay, guys, that's a good thing. Look at that. All those years. Because it was going up 1.9% every year. It's all the way up to 96.4%. Hey, can that go on forever?
Yes.
Guys, do you have more than 100% of your kids graduate?
No.
No, that doesn't make any sense.
But it might not happen.
But our linear representation, Antonio, cannot go on forever. It can't go up 1.9% every year because once it maxes out at 100, it can't go up 1 point. So it would probably be a graph that looks like this, guys. Slowly, and then it maxes out. That should be a straight.
It plateaus.
It plateaus. Good word.
Just like in science.
Right. You can only boil water. It only gets so hot.
True.
All right, last problem.
True.
Until the gas.
Okay. Here's you have 2 of these in your homework. These problems that we're going to do right now. The other ones are even easier than what we did here, but here you have to do you have to graph, draw your trend line, write your equation. These 2 problems are going to take you like maybe 5 or 10 minutes to do, unfortunately. So grab your graph paper. Okay, we're going to make a graph first. The table shows fat and calories for fast food sandwiches. Okay? You guys are growing up a lot healthier than we did. You guys know that there's calories. There's a lot of fat and calories in fast food sandwiches. The more fat, the more calories. Okay? Probably a positive relationship here. All right, construct a scatter plot for the data. Draw and assess a line that best represents the data. You're going to do this, guys, in your own graph paper. So go to your graph paper on the side, and let's make a graph.
Except food has more calories than it used to have.
Now?
Yeah.
It is all made.
Right, there's a lot of processed
It's like
stuff, right?
bigger, too.
All right, I got to open up this graph real quick.
Like, there's like this picture of like a hamburger from like the 70s or something. And that was a hamburger from now, and it was like twice in size.
All right, here we go. All right, what's the only
In
quadrant?
case you guys wanted to know.
What's the only quadrant, guys, we need for a graph this situation? I don't call it quadrant A.
2.
No, it's quadrant 1.
Quadrant 1.
Okay, so draw a y-axis and an x-axis. Okay. You know, make it kind of good size. It doesn't have to be huge, but don't make it like 3 boxes only. Make it good size. Now, looking at your data. This is before you do anything. First of all, which one's the x values and which one's the y values?
Fat is the X.
Yeah, fat's going to be your x. And calories, so we'll put fat, and that's in grams. And then you get your calories on the side. Okay? That's your y value. So label your graphs. Always label your graphs. Should we go by ones on the fat?
No.
No. Okay,
Let's
what's
go by 20s.
20s, you only have 2 boxes.
Fives.
Fives.
Let's go by 5s.
Go by 5s for your fat. So I'm going to go 0. And since I'm going to go every 2 boxes is 5. But you guys can do every 1 box. That's fine. I'm going to go 2. It will be the same. 5, 10. Because I got a big graph here, so I'm going to do by actually, if I go by 5s every 2 boxes, every 1 box is 2.5. Think about that. 20, 25, 30, 35, and then the biggest number is 37, so I can stop at 40. You don't have to go past your biggest number. So does everybody see how I labeled that? All right, now, what's the smallest and biggest numbers from your calories column? Your calories row.
280.
280 is the lowest one.
490.
590.
590. Should we go by ones?
No.
What should we go by?
50s.
You want to go for
Yeah, unless you want to go have a big piece of graph paper.
Good one. You should do like this.
Well, hundreds, you're only going to have like 3 boxes there.
20s.
I think 20s is too small.
50s.
Yeah, let's go by 50s. Let's go by 50s. And,
You wanna skip thing?
yeah, I'm going to make a, what's that thing called when you put a little zigzag thing in there?
It's called the little bridge.
A break. Everybody say break.
Break.
That's called a break. So I'm going to start at 200.
250.
We can start at 250, that's fine.
Yeah, if you drive
I'm going to go 200, 250, 300, 350, 400, 450, 500, 550, 600. We have anything over 600? No, we're stopping at 600, yeah. So that's pretty good right there, people. That's pretty good right there. And again, we made a break in there. You don't have to start at 0 on your calories. All right, now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11 points, guys, graph them. 11 points, graph them. Take your time. 21, 490s. 10 to 80. Again, just estimate. Do your best. 14, 330. 21, 430. 30, 530. 34, 590. Looking like a positive relationship to me. 32,540.
Oh, you're way farther than me.
37,590. 27,550. It's right on the 18,450. And 7,340.
I had to erase it because this was wrong.
Good, Henry.
Oh, I
There's-
Estimation.
Oh, here, do this. Yeah, remember, always do this. First one's always going to be X. Watch. They're going to be
Nine, best.
redo it real quick. Don't erase this one. Just quickly, if you can. All right, now, everybody, you have to draw your line of best fit. Okay, you need a straight edge.
Can I have separate critics of 0 on it?
Armando.
Oh, really? Smart.
Bye, Mandy.
Bye.
Ooh, that's really tough.
All right, now, here's what, guys, when you make your line of best fit, okay, grab a straight edge and try to get the same number of points below your line and above your line. That means you're being fair or even, okay? I tried to put a straight edge up here, guys. It did not go well in the first period. So I can't put a straight edge. But watch, I'm going to do this.
Just don't ask.
Might be a little bit high.
My spaghetti broke.
Okay,
Here's spaghetti.
I'm going to go a little bit lower.
I should have brought some.
There we go. I wish I had a straight. I wish I could do a straight. Oh, I could use.
I don't even understand this.
You don't even understand what?
No, how spaghetti would work.
Oh,
It's straight.
it's straight. It's supposed to be, you know, hard or.
but like it's
firm or whatever. All right, there's my line of best fit.
No, it's
If yours is not perfect, that's fine. But how many people extend your line? Extend your line, make sure it hits the y-axis. How many people's graph hit the y-axis right around 200?
250.
Actually, in last period, we got ours to hit below the 200. This one's above the 200, just a bit. That's fine.
No, because we chose 250 because gift.
Right. But so I'm gonna. All right. Now let's find 2 points that are on the graph. Let's see. This one clearly, I'm gonna use 10, comma 350, and then this one up here looks good, which is 3550.
Bless you.
Thank you.
God bless.
3550. And notice, guys, I didn't go all the way down. You know, the first point I chose was a little bit off the y-axis. That's okay. Okay, those are what I'm going to do. You guys can choose different ones. You're going to have a little bit different of an equation, but it's going to be right. Let's find the slope. 350 minus 550 over 10 minus 30, which is negative 200 over negative 10, which I can do without a calculator. How many people got a slope around 20?
Yep.
Slope around 20. Last period we did it. We actually got a lot, not a lot, but a little bit lower.
Yeah.
We got 13 for a slope last time. Last period we got 13, so we must have done a little bit different of a trend line.
That'd be 20.
Yo, yes, negative 20, not negative 10. So it should be.
Yeah, you're right. Negative 20 at the bottom here. My bad. I subtracted wrong. Thank you. Which does give you a slope of 10, which is better. Because like I said, last period we got 12.5 as our slope. Last period we got 12.5, which is a heck of a lot closer to 10. So how many people got a slope close to 10?
I got 10.
Yeah, okay, you guys just copied what I did. All right,
Why did 250?
I got, looks like 225. My B looks like about 225. Okay, it's half, maybe a little bit below 225, 220-ish, but it's between 200 and 250, so I'm using 225. I'm going to go Y equals 10X plus 225. There's my equation. Your equation should be similar. Doesn't have to be perfect to that. Somebody tell me what 10, don't blurt it out. What does 10 represent? Think.
10 represents.
Think. Raise your hand. What does 10 represent? What do you think, Maeve?
I think it's like 10, and for every 10 fat, there's 225 calories.
No. Well, you're, something like that, but you're using your numbers wrong.
So like 10 grams, it's like starts with 10 grams of fat.
No, because remember 10 is your,
10 calories
10
per
calories
gram of
per
fat.
gram.
It's
Oh, it's
10 calories. Guys, in every gram of fat, there's about 10 calories. Okay? Now, here's the tough question. I don't know if you guys will even understand this.
35.
What's 225 represent?
225 a day.
How many grams?
In
10 a gram of fat.
in 0 grams. Guys, in 0 grams of fat, look, in 0 grams of fat, there's 225 calories.
That's impossible.
No, I think it's possible, isn't it?
And a hamburger?
Maybe like
Well, I think it's impossible to have. Is it possible for a fast food restaurant to have a hamburger with 0
No.
grams of
veggie
fat?
burger.
Yeah, you can.
Unless it's like tofu.
It's like a
Right.
veggie burger.
Right, now maybe it's a veggie burger or
It's
something.
still
But there still might be some calories.
There'd still be like
All right,
butter on it.
Here we go. Back to your notes. Back to your notes.
When they're grilling it, it has
Last
fat.
thing, before we get out of here.
Zero to it. Does that count?
Ketchup's like so bad.
Ketchup's bad for you?
Yeah, it's like all high fructose corn syrup.
And also,
All right,
you should
here
add
we go.
because it's oily.
Y equals, what was it, 10x plus 225? Is that our equation about? Okay, this one's different. The conjecture question is different. Use your equation to make a conjecture about the number of grams of fat in a sandwich with 350 calories. This is different. What do 350 calories represent? The X or the Y? Guys, what do the calories represent? So Y is going to be 350. Your job is to figure out what is X using. So what you're going to do is you're going to take your 350 and plug it in for Y. Okay, and you guys are all excellent two-step equation solvers. You can totally use your calculator here, but we're going to go 350 equals 10x plus 25 plus 225. Subtract 225 from both sides, divide by 10. $10x equals, is that $1.25?
Yeah.
So I can divide by 10 in my head, move my decimal one time.
12.5.
12.5 grams of fat. Now, look back at your graph. What was it? Was it 12.5 comma 350 or 250? What was the Y value? 350. Look at 12.5. 350 was real close. Okay? What kind of checks out? All right, you guys only have about 6 problems for homework, but they were going to take a little bit of time. You will need graph paper and you will need your notes.